Okay guys, welcome back. So what I'm going to do here is a quick tutorial running through all of the things that you're going to need to know that we haven't already covered in class for the Unit 41 3D Environments section. That includes this whole list of stuff here, but more specifically, I'm going to be looking today at some of the things here on the list. So one of the first things I want to talk about are shaders. Now you can create a material in Unity by clicking Create Material, and when you do so, that material will ask you what shader you want. Now most of the time you're going to use either the standard shader, or if you're making particles, then you might use an additive or an additive soft shader. And if I just change from this shader here with all these options to the particle shader here, you can see it changes the options. Essentially what a shader does is it tells the texture how it's going to respond to light, how it's going to be shaded by light, and also gives you a whole bunch of other options, some of which we're going to get into today. So one of the first things I want to talk about are these legacy shaders for the diffuse and specular settings. Now if you go into the Unity documentation and you look at meshes, materials, shaders and textures, you can see in these legacy shader sections here, in the normal shader family, we've got an explanation of diffuse and an explanation of specular. Essentially, diffuse means that when the light hits it, it diffuses along the edge, it spreads out, it's soft, it's matte, it's not shiny, it's not gloss, it looks like you would expect something like brick or cloth or something that doesn't reflect the light back at you to look. That's essentially what diffuse means. Specular, on the other hand, is shiny. So you would use specular for something that needs to be reflective, something like metal or glass or shiny plastic. Now if we have a quick look in Unity, if I just change the shader to one of these legacy diffuse, so I've got diffuse and bumped diffuse. Let me show you the difference. Diffuse has just got one slot for one texture. I can put my cobblestone texture in there, and I've got this diffuse, and if I then drag this material onto something, it will create a material much in the same way that the standard material does. I can still tile it, I can still offset it, I can do the basic things. And a few versions ago in Unity and in Maya, this used to be all you could do. Then we look at bumped diffuse. Now as the name suggests, this has got space for a bump map or a normal map. Bump maps and normal maps are essentially, for our purposes, exactly the same thing. The same is, so here I would be able to drag in, if I was to just pretend for a second that that is a normal map, even though it isn't, I would be able to drag that in there, and now I've got a bumped diffuse texture that's starting to create a little bit of the illusion of depth to it. Not very much, but that's fine. What I could also do, if I go to legacy shaders and change the shader from diffuse to specular, you'll see I get this option here for shininess, and it's still the same material on here, so you can see this in real time. So I can bring it up a bit like that, or down a bit like that, to control how much it's shiny. And again, as before, in legacy, I can go to bumped specular, which would support the same thing and support a little bit of depth, and control the shininess, the amount the light kind of reflects and bounces back off it. And once upon a time in Unity version 3, I think it was, this was all that you could do. However, now we can use a lot more sophisticated sorts of shaders with a lot more depth of options in the main Unity standard shader. So we still have albedo, we still have normals, we still have heights, and we have a whole bunch of other options as well. And I'm going to talk about all those things now, starting with albedo. So the albedo is the base color control in the standard material shader in Unity. And if I go over here and have a look at it, you can see that I can drag a texture into it. The material's on here. I can also change the color hue that that texture might get. And crucially, I can control the transparency. Now this particular texture, because it's a JPEG, not a PNG, doesn't have any transparency. But if there were some see-through bits on the texture, by dragging this slider here, it would make them more see-through, more transparent, or less see-through, more opaque. I'm just going to reset that to base white. In addition to albedo, you've got this smoothness, which as you can see makes it less smooth and so more diffuse, or, just click back on the material, makes it more smooth and so more specular, more shiny. These are parameters that are controlled in the standard shader of any material. But Albedo is a little bit more than that, just a little bit. So for a start, as you can see in the Unity documentation, it controls the base color of the surface. One of the things that it's important to remember for the albedo, it says so down here, is that it should not contain any lighting. Now what that means is you might have a texture where you've painted the effect of light on. You don't want that. You don't want light to be painted on to the texture. You don't want her highlights of her face to be painted on as though light's already shining on it from one angle, because when you put that on the model, that will stay on the model regardless of where any light in the scene is. So if the light's coming from over here, but her face is painted so it's coming from over here, it's just going to look a little bit weird in the scene. So generally speaking, you shouldn't be painting light directly onto the texture because the light will be controlled elsewhere. Final thing, as I've already talked about, is the transparency, which allows you to change the alpha channel if the texture type supports it. So if you've got PNG textures that have transparent alpha channels, things that look a little bit like this, which is one of the things I use for my particle texture, my basic water particle, that is a PNG, and so all these white bits here will disappear when it's viewed in Unity as my particles come gushing out and they don't have white sections on them. But that's because they're PNGs. That's because the type of texture file that I've put on there is a PNG file, not a JPEG file. So here are some examples from the Unity documentation, and again you should take these, of what you might be using this alpha channel for, this transparency for. For example, if your texture supports the illusion of broken windows, which is very, very easy to do in Photoshop, like this, then that illusion of them being broken and transparent and completely see-through will be preserved when you put your texture on in Unity. Okay, so now on to normals and height maps and the difference between the two. So before we can get into the differences, because you are going to have to explain what the differences are, it's important to understand what bump maps do. So if we have a quick look at the Unity referencing manual here, you can see this geometry here. There are two ways that you could create this geometry. You could create a massively large polygonal structure like a cube here with loads and loads and loads of geometry, a bit like the terrain tool almost, and then kind of cut into it and bring all these bits down and raise these bits up if you wanted to. Each of these tiny rivets could be its own piece of geometry with, I don't know, 400 polygons or so, and then multiplied out, multiplied out, multiplied out. But that ultimately eats up a lot of runtime. So a better way to do it is to create the illusion of depth using a normal map or a bump map. Okay, so how do they work? Well, if you think about the way in which an object is lit, what you've got here, and this is from the Unity referencing manual, what you've got here is you've got two different ways of looking at the same 12-sided cylinder. One of them has got flat shading here, so you can actually see the 12 bits that make it up, and one of them has got the normals smoothed. It's possible to do this in Maya. You've got two cylinders here, 1, 2, by going to this one, mesh display, and by softening the edge. This effectively achieves the same effect of smoothing the normal, smoothing the way the light plays off these jagged edges. And that's essentially how bump mapping works. If we take a quick look down here, what you see here are the representation of 3 of these edges, 1, 2, 3, where they meet here. And this is what happens when light hits them. It kind of bounces off pretty much straight in the direction, straight back in the direction that it's coming on it here. As it says here, the surface normals are represented by the orange arrows. These are used to calculate how light reflects off the surface. Now this is the usual way of doing it. However, what that achieves ultimately is this sort of smooth, roughly smooth curve here. But with bump mapping, what you can do is you can change the way the light plays off the surface. So you're not actually changing the surface. What a normal map does, you can see here with the purple and pink shading, that's very similar to the way a normal map appears here. What that does is it's telling it when the light hits it, don't bounce straight back, bounce into these divots here to create shadow, or bounce outwards at these wild angles to create the illusion of raised areas. All of this stuff is in the Unity documentation, and you should screen grab this stuff to explain what you need to do. So ultimately that is how you create the illusion of bits that go in and bits that come out. It's just what the light is doing when it hits it. And by putting a normal map, in addition to the main base albedo texture, you can create the illusion of something like this without actually increasing the geometry. So height maps work slightly differently to achieve the same effect. Whereas normal maps change the way light bounces off the object and so create the illusion of depth and shadow, height maps actually pull areas of bump, the white, towards the camera. They create the optical illusion that the white areas are being pulled out towards the camera and that the black areas are being pushed in away from the camera as the camera moves around the object. Now this, as it says here, is more complex and also more performance expensive. The reason for this is because it's creating a real-time camera effect, a rendering effect that happens 30 frames per second that creates the illusion of pulling bits of the wall out whilst leaving other bits of the wall in. Essentially creates these kind of divots and bumps. And you can see the effect here of with just the albedo. This one is with the normal map assigned, so it was starting to create the illusion of light bouncing off it in different directions. But here, from the angle the camera is looking, it actually looks like some of these stones are starting to be pulled out. So whereas normal or bump mapping changes what light does, height mapping actually changes the way different bits of the texture react when the camera passes past them, creating a better effect, but for higher intensity. Okay, now I'm going to do my best to explain the difference between specular and metallic setups. And I'm going to do so with the help of two visual aids. This basic brass texture here, and this slightly more detailed patterned texture that I'm going to put on the brass. So what we've got in Unity is I've got 3 different brass pins, and each one of them, I'll just frame it on this for a second, each one's got a slightly different shader. So I'm going to take a look at this one first. This just contains the standard shader with only a texture, the normal brass texture, that's this one, in the albedo state. And I can drag the metallic along, and you can see it's reflecting the skybox. If I just rotate, you can see all 3 of them reflect the skybox in the background and the sun in the skybox. They essentially reflect the light source, the main light source that's been identified in the skybox. But this one is a fairly basic bog standard pattern. Now in the standard setup, I can change the smoothness, so I can bring it right down so it doesn't reflect anything at all. I can change the metalness, though with the smoothness turned off you won't get as much effect on that. So it just looks like a normal bog standard boring piece of diffuse texture. If I bring the smoothness up a little bit, you'll see it starts to bring more of the sun in. It starts to bring more of the light and eventually more of the skybox in. This line running through the middle of it here is the skybox. If I bring the metallic setting in as well, you'll see that it starts to become very, very shiny and almost like a polished surface, like a mirror. And if you're using something like a chrome fender, you might turn the metalness and possibly the smoothness all the way up, so that pretty much all you're getting is hardly any of the texture at all and most of the light that's being reflected from this surface. But I also want to talk about these 2 other shaders. I'm just going to put this one back to normal so it's a good contrast. It's kind of sort of roughly in there, somewhere in the middle. This is the standard shader, but in the albedo, I've got my basic brass texture here. And in the metallic, I've got this kind of detailed texture down here. And you can see already it's starting to bring some of the pattern from this detailed texture in there. One of the things I can't do using it in the metallic setting here, that I would be able to do if I used it in the detail down here, is I can't change the tiling. You can see here I can change the tiling. But we'll get to detail albedos later. For the moment, if I've got the standard shader with the albedo and the metallic option, you'll notice, different from this shader, I've lost the slider on the metallic. Here, this is what the metallic is rendering, and I can bring the light source right down, or I can push the light source right up. Right down, you're hardly getting any of that secondary metallic texture in there at all. But bring it right up so it's bringing the light in, and you're getting a lot more. Add a normal map and a height map in there as well, and you'll probably get a lot of detail from the divots that are in there. But ultimately, it's still reflecting just pretty much light. It's reflecting which bits of yellow light are visible here, which bits of yellow light are visible here, but none of the colour. Finally, if we change the shader from a standard to a specular setup, you'll notice I get this specular option. And if I drop the same brass texture in here, just frame in on this one for a second, drop the same brass texture in here, you'll notice I'm starting to get some of the colour of the skybox reflected as well, something that I'm not really getting as much of in here. So if I click on this, you'll see again I've got the smoothness option, so I can completely take the light source out. I can have blinding light, or I can have a highly polished surface like before with a little bit of detail in there. So if we quickly look at the Unity documentation for this, don't get too bogged down in its explanation of the specular parameters here being controlled by the RGB. What this essentially means is that which bits of it are shiny, which bits of it are white and reflect the light, is going to be controlled by the balance of red, green and blue that makes up the pixels. So the more of that there is, the whiter they are. That's going to control the specular parameter here. The smoothness of it, the amount that it smooths out and reflects light from the source, is going to be controlled by the alpha channel. So the more transparent it is, the more diffuse it is, I think. But don't get too bogged down in that. What's important is this last bit here. It's very useful to use this specular parameter if you've got a single texture map, i.e. something you've UV'd, that contains multiple different surfaces, such as leather shoes, the fabric of clothes, skin for hands and face, and metal buckles. Where specular is useful, what it's good for, is if you've got one UV map with lots of different materials in it. What will happen then, when you start dragging the smoothness, is the materials that are supposed to be metal will look more metal, but the other materials, the other bits of the texture that aren't supposed to be metal, will look less metal. So the standard material with a specular setup is very useful if you have a UV map with lots of different sorts of materials in it: metal, skin, clothes, leather, and so on and so forth. So the final thing I want to talk about today is detail textures, detail albedo. Here you can see we've talked about this a little bit already in the context of this brass texture here, changing the level of detail on here and being able to tile textures here. Essentially, if I just frame in on this for a second, essentially what a detail texture allows you to do is to add another texture over the top of the one that you've used before. And the example that they use in the Unity referencing manual is where you might add little pits to skin textures. So you've got the basic skin texture here that controls colour, but the surface detail of that, the little pits and sort of divots and scar tissue that goes in on everyone's skin, is controlled by a second layer, in this case a detail layer. Now I wanted to take a look at this in the context of these two brick walls, because one of the things that this is really useful for, I'll just move these around a little bit here so they're in frame. One of the things that this is particularly useful for is making your walls look just a little bit kind of dirtier and grubbier and less clean and more like an old real wall rather than a brand new wall. So at the moment I've got these two brick walls and they've both got this brick material here which has got an albedo and a normal map on it. Now what I'm going to do is I'm going to duplicate this material, and I'm going to say that this is going to be a material with detail as well. And what this gives me the ability to do is add another texture on top of this. Something like this lichen texture, for example, that grows in the divots of the cement on most real walls in the real world. So what I'm going to do with my new detail material, just check that this one's got the standard brick material. This one needs to have the new material here with detail so we can see this in real time. If I go into my detail material here and I come down to the detail albedo, I'm going to drag in the lichen here, and you can immediately see that it's made a difference. If we zoom in, we can perhaps see the sort of difference that it's made. The lichen is now visible, very visible in these areas of the wall here with the bump map on it, and slightly less visible in the other areas of the wall. But wait, there's more. Secondary maps will also support a normal, and if I drag the normal in here, then it adds just that extra level of depth to the detail albedo. I've just created this normal map in Unity, so it's not a proper one here. But you can tile this to change the flow of the texture on there. If I put it to maybe 3 by 3, and remember, of course, to put the detail map to the same, then you can see what I've got now is actually starting to look like a real brick wall, rather than this wall over here, which kind of looks like a fake brick wall, brand new, but not very real. So if we just quickly flip back to the Unity documentation here, it says it allows the material to have sharp detail when viewed up close, whilst having a normal level of detail when viewed from further away. The advantage of this is, by using two different textures, you don't have to use a single extremely high texture map. What that means is you don't have to use a texture map that's 4096 by 4096, which is really going to slow down your game. You can use two texture maps that are, say for example, 512 by 512. So you can do this with all sorts of different types of texture. And by adding that normal map as well, it really makes a difference when rendered up close. Thank you very much for listening, and do please stay tuned for the next update where we're talking about Unit 31 3D environments.